Today we're going to talk about circumference, arc length, and area of circles. So the first thing is the circumference of a circle is really the perimeter of the circle. And our formula could either be based on the radius or the diameter. So C could equal pi times d, so pi times the diameter, or 2 pi r, because the diameter is really 2 times the radius. So pi d or 2 pi r, so depending on what we're given or what we're looking for, will determine which formula we'll use. So first we just want to find the circumference of a circle with a radius of 14 centimeters. So because it gives us the radius, we're going to use C equals 2 pi r. So we're looking for C, and that's equal to 2 pi times 14. So our calculators, we should be able to pull up a pi symbol. So let me pause for a second, so I'll pull up my calculator and show you where it is. All right, so here I have the kind of calculator that we have in our classroom. So I don't know if you could see it, but the pi symbol is small here in blue above the raising to a power symbol. So if I wanted to do 2 times pi times 14, I would have 2 times, I'm going to hit second and that button, so now I have the pi symbol, times 14. And I get 87.96. I'm usually going to round to the hundredth for these. And if there was a unit for the radius or diameter, we're going to include that unit in the circumference. So this is going to be centimeters. So you go ahead, try this one. Find the circumference of a circle when the diameter is 43. Pause when you're ready to see the answer, hit play. All right, so we would use pi d for this problem. So that's pi times 43, and I get about 135.09 inches. All right, our next example, we want to find the diameter of a circle with a circumference of 28 meters. So I'm still using the circumference formula, and I'm using the one that has diameter in it, C equals pi d. So this time, I'm going to put 28 in for the circumference, which means to get d alone, I'm going to have to divide by pi. And doing that, just using the pi button on the calculator, we would get d equals 8.91 meters. So you're going to try the next problem. We're looking for the radius this time when the circumference is 4. Pause when you're ready to see the answer, hit play. All right, so if you notice, we get an answer of 0.64. If you did not get that, I would recommend dividing separately. So first I divided by 2 to get pi r alone. And once I had pi r alone, then I divided by pi. If you try to divide by 2 pi, some calculators might think you're dividing by 2, but then multiplying that answer by pi. So you either have to use parentheses if you want to do it all at once, or do it in 2 separate steps. So the next thing we're going to talk about is arc length. So we know that arcs are the portion of the edge of the circle, and we could actually measure that as a unit of distance as well as measuring it in degrees. So its measure would be in degrees, but its length would be in inches or feet or meters or something like that. So we're going to set it up as a proportion because this is part of the circle. We're going to put the degrees of that arc over the total circle degrees, which is 360. And then the other side is going to be the length of that arc over the length of the whole circle, which happens to be its circumference. And depending on what we're doing in the problem, might change whether I'm going to use C equals 2 pi r down here, or if I'm going to use pi d, or if I'm just going to use the letter C. So our first example, we want to find the length of arc PQ. So arc PQ is over here. We know it's degrees over 360 equals the length over the circumference. I'm going to be just shortening it up here right now. So this was 75 degrees over the 360 equals The length is what I'm looking for, so x over, and I'm given the diameter. So it makes the most sense to use pi d down here, so that's pi times 9. So I'm going to cross multiply, right? This is a proportion, cross multiply here, so we get 360x equals 75 times pi times 9. So when I do all of that, I get 2,120.58. I'm actually going to just keep that in the calculator and hit divided by 360. So I get a length of about 5.89, and that's in terms of yards. You go ahead, try the next problem, pause, when you're ready to see the answer, hit play. All right, so the degrees were 60 over 360 equals x over, and I'm given the radius, so I'm using 2 pi r, so that's 2 pi 8. So cross multiply, we get 360x equals 3,015.93. Dividing by 360, we get about 8.38 centimeters. Here, I'm given the length of arc RS because it's not giving it to me in degrees, it's giving it to me in terms of meters. I'm looking for the measure, so I'm looking for the degrees. So when I use my proportion of degrees over 360 equals the length over the circumference, I'm actually putting x in place of the degrees because the length here is 44. And I know the radius is 15.28, so we're going to use 2 pi r, so 2 pi 15.28. So this is going to end up being 2 times pi times 15.28, 96.01. So 96.01x equals 44 times 360, we get 15,840. And I'm going to divide by my answer, and I get about 164.99 degrees. If you said 165 at this point, I'm probably okay with that. All right, another example together. I'm looking for the circumference of circle Z. So again, knowing I'm using degrees over 360 equals the length over the circumference. We know the degrees are 40 over 360. I know the length is 4.19, and I'm looking for the entire circumference. I'm not looking for the radius or the diameter. I'm looking for all of C, so I could leave it as the letter C. So now when I cross multiply, I have 40 times C equals 360 times 4.19, which is 1508.4, and divide by 40, I get a circumference of about 37.71 inches. So you go ahead and try this one. You're looking for the circumference of circle N. Pause. When you're ready to see the answer, hit play. All right, so I end up with 270 over 360 equals 61.26 over C, and I get C is about 81.68 meters. All right, in example 6, we have the dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So one full revolution would be the perimeter or circumference of the circle. So I'm really looking for 15 times the circumference. So let's find the circumference first. We know that the diameter is made up of all these pieces, the 5.5, the 15, and the 5.5. So I have a diameter of 26. So if the circumference is pi times d, and I have pi times 26. I'm actually going to leave this as 26 pi for a second because I know I'm going to multiply this by 15. So I get 390 pi, which on the calculator tells me it's 1,225.22 inches. And I'm going to go back to the original problem. To the nearest foot is the question. So that means I'm going to take the number of inches and divide it by how many inches are in a foot, which is 12. And I actually get about 102 feet. All right, another example here. The curves at the ends of a track shown are 180-degree arcs of circles. So basically, they're showing us that if I were to draw the diameter here, this portion is half of a circle. And the same thing's going to happen at the other end. The radius of the arc for the runner on the red path shown is 36.8 degrees. Now, how far does this runner travel to go once around the track to the nearest tenth of a meter? So I'm going to find the distance here, the distance here, the distance here, and the distance here. The first two are straight lines, right? That's 84.39 plus another 84.39. The other two parts are each half of a circle, which means together they form one single circle. So I'm going to add to this the circumference of a single circle that has a radius of 36.8. So that's 2 pi 36.8. So this is going to be 168.78 plus 231.22. And it says to the nearest tenth, but I actually get a whole number here. I get about 400 meters. All right, you're going to try this check-in. You're going to find the perimeter of this shaded figure. So that means you're adding up the pieces that are straight and the pieces that are curved. All right, pause when you're ready to see the answer, hit play. All right, so the four straight pieces were each 2, so 2 plus 2 plus 2 plus 2. Then I had 4 quarters of a circle, and 4 quarters of a circle is really one whole circle. And each of those circles also had a radius of 2. So that was one full circle. Find the circumference, radius of 2. So we get a total perimeter of 20.57 units. All right, now we're going to talk about the area of a circle. So the area of a circle is pi r squared, where r is the radius of the circle, right? And area is talking about the amount of space it takes up. So let's start by finding the area of a circle with a diameter of 32. We no longer have an option for a formula including diameter, so we're going to have to convert this into a radius. So half of 32 is 16. So we're going to find the area of a circle that has a radius of 16. So on the calculator, I'm actually going to do 16 squared first and then hit that answer times pi, just so we make sure we're not accidentally squaring the pi as well. So 16 squared is 256 times pi. We now get 804.25, and area has square units. So this would be feet squared. You try the next one. Find the area of a circle with a radius of 8.5 inches. Pause when you're ready to see the answer, hit play. All right, so we get about 226.98 square inches. Now I'm going to do a little working backwards. I want to find the radius when the circle has an area of 176.7. So I'm still taking the formula of a equals pi r squared, But instead of A, I'm going to put what the area was. 176.7 equals pi r squared. So I want to get r squared alone, which means I have to get rid of pi. So I'm going to divide both sides by that pi. And when I do that, I now have 56.25 equals r squared. So to get r now, I'm going to take the square root of both sides. So I get about 7.5 feet equals r. You can go ahead and try the next one. Pause. When you're ready to see the answer, hit play. All right. So this one, ooh, I didn't even check my answer here. Find the diameter of a circle with an area of 153.94 square feet. So I do all this work and I get a radius of 7, but that's not exactly what they asked for. They want the diameter. So I need to multiply this by 2, and I actually get a diameter of 14 feet. All right, we are almost done. We're going to talk about population density. So population density of a city, county, or state is a measure of how many people live within the given area. So population density is really the population or the people over the area. All right, and that's how we find population density. We take how many people and divide it by the area they are living in. So for our first example here, about 124,000 people live in a 3-mile radius of a city's post office. Find the population density in people per square mile. So density equals the people over the area. We don't know the density, that's what we're looking for. But I know the people living there is 124,000. And I know if it has a radius of 3 miles, the area is pi 3 squared. So I'm going to do pi 3 squared first, and then I'm going to divide 124,000 by that, and I'm going to round this to the nearest whole number. So I get a density of about 4,386 people per square mile. So our density should include the units here, people per whatever unit it was for our area, in this case, square miles. So you go ahead and try this one, pause, when you're ready to see the answer, hit play. So we get about 4,615 people per square mile. For our last example, we now have a region with a 10-mile radius, has a population density of about 869 people per square mile. We want to find the number of people who live in the region. So if I'm still taking density equals people over area, this time I know the density is 869. I don't know the people, so that's going to be a variable for me. And the area is based on pi r squared, so that's pi 10 squared. So I'm going to multiply 869 times pi 10 squared, and I get about 273,004 people. So you're going to try this last one, pause, when you're ready to see the answer, hit play. All right, so I have 1,000 equals x over pi 3 squared, so I get about 28,274 people. And that is everything about arc length, circumference, and area of a circle.